Okay, so on the previous lesson, we just did these solids generated for rotating about an x-axis or a y-axis. So sometimes the axis of revolution is something else. Like, for example, on this first one, we're going to, we have this region Q. That is bounded by the curve y equals x cubed, the y-axis, and the horizontal line y equals 8. We're going to set up and evaluate an expression that gives the volume of the solid generated when Q is rotated about the line y equals 8. So y equals 8 is up here. That is our axis of revolution. Okay, so in the previous lesson, I'm going to go through the same way. So what we're going to do is draw a radius from the axis of revolution to the curve. All right, and then we're going to represent that radius with an expression. And what I told you guys to do yesterday or the previous lesson is the same thing I want you to do on this lesson, which in this case, where that radius is a vertical line, we're going to do top minus the bottom. All right, so the top in this case is going to be 8. And then the bottom in this case is going to come from the curve y equals x cubed. So 8 minus x cubed is our radius. All right, so when we set up our integral, is for all these revolutions, they always form circles of some sort. So it's pi times the integral. All right, we do need to figure out this point right here. It looks like it's 2, but let's just make sure. So I do know the y is 8, and the number that you cube to get 8 is 2. So we're filling in all the radii from 0 to 2. So those are our lower and upper limits. And then it's going to be the radius squared dx. Okay. And then we're going to use the calculator to do this. Now, don't be surprised if you would have to do this one by hand on the AP test. It's very doable. The thing is that I want you guys to kind of get comfortable doing the integrals and not have to focus on the tedious steps of like evaluating them. So anyway, we're going to do pi and then alpha window to get the integral. Number 4, fill in our lower and upper limits. Now we cannot use their parentheses, so we have to put this thing right here inside of their parentheses. Okay, so that should be it. We need to be accurate to 3 decimal places. Okay, so let's look at the next one. All right, this one's a little bit more difficult for a couple of reasons, but we have this region P, and it is bounded by the curve. This is the natural log of x minus 1. It was bounded by that. The x-axis and the vertical line x equals 10. So we're going to set up and evaluate an integral expression that gives the volume of the solid when it's rotated about the line x equals 10. So that is this line right here. This is your axis of revolution. Okay, same exact words. We are going to draw our radius from the axis of revolution to the curve. That's R. Now, anytime that you draw that and it's horizontal, it's a horizontal radius, then this curve needs to be in terms of Y. So we have to solve it for X. So I'm going to come down here and do that. So to solve it, you basically e it or exponentiate it. So it's e to the y equals, it would be e to the natural log of x minus 1, or e to the y just equals x minus 1, because that would cancel out. And then to solve that for x, you would add the 1. Okay, so now in this function, or this integral, when we're using this curve, we're going to use this, not this. Okay, so to represent the radius, so if it's sideways, when it's your radius is horizontal, you're going to think right minus left, right? And in this case, the right is 10, and the left is the curve, which we will use e to the y plus 1. Now, it's important that you put that in parentheses, because you have to subtract that whole thing. Now, whenever I set up mine, especially since this is a calculator problem, there's no reason to even worry about distributing that and simplifying it. Don't do it. Just leave it messy. It's fine. So we do need to figure out our upper and lower limits. So what we're doing is we're filling in all of the radii from 0 to some number here. Now it looks like it's 2, but we're not really sure. So we're going to have to make sure. Oh, sorry. I closed out my calculator. So I do know that the x is 10. So what we would do is just go to the calculator. And here we would put 10 in for x. So you would do the natural log of 10 minus 1, or the natural log of 9, however you want to do it. All right, and then we'll just go to several decimal places. So I'm gonna say that it's A. That's good enough. Okay, so when I set up this, I can just use A for that. And then it's going to be the radius, which is 10 minus, and then in parentheses, e to the y plus 1, close those parentheses, close another set of parentheses, squared, dx. Okay, well, let me show you what we're going to do in the calculator with that. Oh, shoot. Okay, so I have that in my calculator, so I'm just going to go ahead and store that as A. Right, so now when I do my integral, okay, and then I put all that stuff in my own set of parentheses. So lots and lots of parentheses here. I'm going to go ahead and use y. You technically can just keep using x. So close the parentheses on that, close another set, square, and then dy. All right, and you guys, that's right, sorry. You guys should really practice typing this in also, because in class, there's a lot of people who are really struggling typing in the integrals. I hope this helps.